Okay, so picking up where I left off on that last one, multiply the top, 2400 times pi times 7.5, and you get 18,000. I need to get the pen. 18,000 pi. And then on the bottom, 60 times 12, we get 720. And divide the 18,000 by 720, and you get 25 pi, and the units were feet per second. And you can leave things in terms of pi. If you want to type that in and get a decimal, that's okay too. Okay, last problem. Oh, I forgot to write down. This was 109. That was number 109. Okay, now we're going to do, the last problem we're going to do is 111. Okay, this one is the DVD player. So we've got a DVD that's approximately 12 centimeters in diameter. And it says that the drive motor of the DVD player is controlled to rotate precisely between 200 and 500 revolutions per minute. And it says depending on what track is being read. So you know how on DVDs okay, depending on what track is being read. If you think about it, like a point here rotating around versus a point here rotating around. See how this point would have to go faster because it has more ground to cover than this. So this is going a little slower and this is going a little faster so that they're all going around at the same, so that they would be located at the same spot. Again, because this has more, it has a farther distance to go, so it has to go a little bit faster to keep in line with this one. So that's why there's that varying degree. Okay, so for part A, we're supposed to find an interval for the angular speed of a disk as it rotates. So angular speed, that's radians per some time unit. Well, they gave us minutes, so let's just stay with minutes. Radians per minute. Okay, now we have a range of values, 200 to 500. So let's start with 200 revolutions per minute. And we want to convert that into radians per minute. So if revolutions are on top, revolutions have to go on the bottom. How many radians are there in one revolution? Well, there's 2 pi radians in one revolution. So that means that this would be 400 pi radians per minute. Now what about 500? 500 revolutions per minute. Again, there's 2 pi radians in one revolution. So then this would be 1000 pi radians per minute. And so to answer the question, it says, find an interval for the angular speed of a disk as it rotates. So the interval would be 400 pi to 1000 pi radians per minute. That would be the interval. Okay, now for part B, it says find the linear speed. Okay, linear speed would be like feet or inches or centimeters per some time unit. Well, since our diameter is in centimeters, it would make sense to do centimeters per time, which they gave us in minutes, so we might as well do centimeters per minute. Okay, now it says find the linear speed of a point on the outermost track. Outermost track. as the disc rotates. So again, remember how it has to go faster on the outermost track because it has a longer distance to cover. So we want to go with the 500 revolutions per minute. And we're going to convert that into centimeters per minute. So we've got the minutes part, but now we got to get revolutions into centimeters. How many centimeters are there in one revolution? So again, one time around, that's called the circumference. Circumference is 2 times pi times the radius, or 2 times the radius is the diameter. So you could say pi times the diameter, because we were given the diameter of 12 centimeters. So that means there's going to be pi times 12 centimeters, pi times 12 centimeters in one revolution, one time around. So revolutions cancel. So now you have 500 times pi times 12, which is 6,000 pi, technically over 1. And the units are centimeters per minute. And that's the answer. Okay. So hopefully you've watched all the videos, and hopefully this helped you on some of the homework problems. And I will hopefully be back at school tomorrow. Okay, goodbye.